Hello everyone, this is Professor Keen. This is the fifth in a series of lectures on astronomy for my Physics 101 class. For the last few lectures, we've been talking about Stellarium software, which is a fairly complex piece of software that can be used for stargazing at the comfort of your personal computer. One of the problems I find with Stellarium is that it has so much functionality, it has so many things that it can do, that it sometimes is a little bit overwhelming. So I do encourage you to download the software and spend some time playing around with it, familiarizing yourself with it, and getting used to it, because I think it'll really come in handy over the course of this semester. I also think that there might be just some simpler ways to think about things. If you're having a little bit trouble with Stellarium, I want to present you with a couple of diagrams that might provide a simpler explanation of some of the stuff I've been talking about. So let's take a look at the slides that I have on my desktop right now. On this slide, which I think I got this image from, it might even be from Wikipedia, I don't remember where I got it from, but this slide indicates the path of the sun on the summer and winter solstices for an observer who is standing on the equator. So this is kind of a cartoon. You imagine you're standing on that island in the middle of the diagram with the palm tree. The four green arrows represent you looking out to sea in different directions. The one that's kind of coming back toward us and to the left, that's in the northerly direction. The one going away from us to the left is looking in the eastward direction. The one pointing away from us and to the right is in the southerly direction, and the one pointing toward us and to the right is in the westerly direction. And so this is if you are standing on the equator. Then as you look to the north pole of the celestial sphere, which is shown as this grid of blue lines, is going to be right on the horizon. And then what happens on the summer solstice, the sun will be rising to your east, but it will be in the northern part of the sky and will follow this trajectory across the sky on that particular day on the summer solstice and set in the west. After the summer solstice, it will also be traveling around as this sphere, the celestial sphere, is rotating it, but it's going to be rising farther and farther in the south direction until on the autumnal equinox, it is rising directly to your east and following this line directly over your head and setting directly to your west. That would be on the autumnal equinox. Then, as the year progresses, the sun will be rising further and further and further to the south until finally, on the winter solstice, the sun rises to your southeast and it travels in this trajectory across the sky and sets to your southwest. So again, this is the daily path of the sun on the summer solstice all the way over to the winter solstice for an observer that's standing on the equator. Of course, after the winter solstice, then the sun starts migrating back in the northerly direction. So just after the winter solstice, it rises perhaps here and travels over like this and sets in the west and once again, and by the time you get to the summer solstice, again, it is rising right here. Let's go to the next slide. Now, this is the situation, the same situation, but instead of an observer who's standing right on the equator of the Earth, like in Quito, Ecuador, he's standing at about 20 degrees north latitude. So this might be somewhere in Mexico, or on an island just off the coast of Mexico, as is indicated by this little sandy island with the palm tree on it. Once again, this is showing the daily path of the sun on the summer and winter solstices for the observer standing at 20 degrees north latitude. Notice once again, as the observer looks northward toward the horizon, again, the North Star is in this direction, but now it's not directly on the horizon. The North Star, which is on the pole of the celestial sphere, is right here. So the whole globe is tipped a bit. So when the sun rises to the northeast on the day of the summer solstice, it goes up like this and it sets once again in the northwest. And then as the year progresses, we get to about September 20th, 21st, and on that day, the sun will be rising directly to the east. It will be traveling through the sky and setting directly to the west. Then as the autumn progresses, by the time you get to the winter solstice, the sun is rising in the southeast and going over the southern part of the sky and setting in the southwest. So once again, you can see this celestial sphere rotating around as a model for understanding the motion of the sun at various times during the year. Let's go on to the next slide. Here we show, once again, the daily path of the sun on the summer and winter solstices for an observer who's now standing at about 50 degrees north latitude. So this would, so Wauwatosa is about 43 degrees north latitude, so this is 7 degrees farther north, perhaps in northern Minnesota, southern Canada. In this case, once again, if an observer looks toward the north, the northern horizon, well, the North Star will be somewhat higher up in the sky, right here, and this celestial sphere will be rotating once again around this pole. Notice now that the sun rises fairly far to the northeast, and then it travels in an arc across the sky, and at noontime it is in the southern part of the sky, and then it sets over here in the northwest. That is on the summer solstice. Notice in particular that the sun is up in the sky for a very long time during the summer month. That's precisely because of the tilt of this celestial sphere from this geocentric perspective. By the time one gets to the autumnal equinox, the sun will be rising directly to the east, traveling through the southern part of the sky from the perspective of the viewer, and setting directly in the west. And then as autumn progresses toward the winter solstice, now in the winter solstice, the sun will be rising in the southeast, and it will be really hugging the horizon, only traveling perhaps 20-25 degrees above the horizon by noon, and then setting in the southwest. So this is the perspective of the trajectory of the sun throughout the year for someone standing at about 50 degrees north latitude. You probably see where I'm going with this. Let's walk even farther north. That's the next slide. Here, this is the daily path of the sun on the summer solstice for an observer standing at 70 degrees north latitude. So this would be someone who's standing above the Arctic Circle, which is at about 67 degrees north latitude. Notice how the North Pole, or the pole star, is nearly overhead for this observer. So, on the day of the summer solstice, the sun is going around in a circle as this sphere rotates, and for a significant part of the year, the sun never sets below the horizon. It will be high up in the sky, in the southern part of the sky, at some parts during the day, and it will be low in the sky at other parts during the day. But there will be several days, perhaps several weeks, where the sun does not set below the horizon. Notice also that on the winter solstice, the sun never gets above the horizon. There are some shadows here that indicate the position of the sun, its trajectory during the time of the winter solstice, as it's going around below the horizon of the person standing here at 70 degrees north latitude. I don't have another slide indicating what would happen if someone's standing directly on the North Pole, but you might ask yourself, how would this celestial sphere look? And what would be the trajectory of the sun for someone standing on the North Pole? And the answer to that is that the North Star would be directly above the observer, and this celestial sphere would be rotating around them once per day. All right, I hope that gives another way of thinking about this. I found that when trying to understand the motion of the sky, which is frankly quite a complicated thing, that by looking at it from several different angles, using several software packages and several different ways of understanding it, one can begin to get a grasp of this. Again, if you don't quite get this yet, don't sweat it. We're in the first week or two of classes. We'll have lots of opportunities